Good evening, students. So in today's class, we will be discussing the topic questions on the topic relation and function. Okay, we will be discussing the questions on the topic relation and function. So in today's session, first we will be discussing 3 mark questions. Just students, those who are on the mic, you all just take it off. Students, those who have, those whose audio is on, just off it. Those whose speaker is on, just off it. Okay, so we will continue with the class. Yes. Mhm. Okay, so see, pay attention now. So, in relation and function, okay, in relation and function part, okay, so in relation and functions, okay, so today we will be discussing the questions on relations and functions. So, in relation and function part, okay, so we have actually a 3 mark question, a 5 mark question, okay, 3 mark and 5 mark. Very important questions are there. So in 3 mark section, every year a question is been asked on reflexive, symmetric, and transitive. Okay, okay, and equivalence relation. Okay, so if the relation, we need to check whether the relation is reflexive, symmetric, and transitive, and if it is exhibiting all the three, then it will be a equivalent relation. Okay, so we need to show the relation is equivalence relation. Okay, so every year a fixed question is asked for 3 marks on this concept, that is reflexive, symmetric, and transitive. So in today's class we will be discussing this question, and then a 5 mark question is also fixed from this chapter. A 5 mark fixed question is been asked every year. Okay, that we will be discussing it tomorrow. Okay, so we will start with our discussion on the 3 mark question from relation and function. Okay, so to begin with, first we need to know the definitions of these three statements over here. So pay attention. In short, I will explain you, and then we will begin with the question. So first, so whenever we are defining a relation, okay, we are defining it on a set. Okay, and we know a relation is nothing but it is a subset. It is a subset of a Cartesian product. Okay, it is a subset of a Cartesian product of two similar sets or two different sets. Okay, so always it is a subset. So we need to check whether this relation is reflexive. It is it reflexive? Reflexive. So for reflexivity, and then whether it is symmetric and transitive. Okay, transitive. So we need to check these three. Okay, so which whether the given relation is of exhibiting reflexivity, whether it is symmetric or transitive. Okay, so in case of reflexivity or for reflexive a relation is said to be a reflexive relation. Okay, if the condition is ordered pair a comma a belongs to R. Okay, for all A belongs to A. Okay, so we need to understand the meaning of this. Okay, so ordered pairs which are present in the relation. Okay, on the in the relation. Okay, so these ordered pairs, that is A comma A ordered pairs, must be belonging. Okay, must be present in the relation for every element of A, or for every element of A. So if the set A is having two elements, okay, if it is having suppose two elements, 1 comma 2, then the ordered pairs 1 comma 1, okay, 1 comma 1 as well as 2 comma 2, both these ordered pairs must be present in the relation. Then we can say it is a reflexive relation. So for every element, so if three elements are there, then the ordered pairs of the form what A comma A must be present in the relation. Then it is said to be a reflexive relation. Okay, ಅವಾಗ ಇದಕ್ಕೆ reflexive relation ಅನ್ಬೋದು. Okay, so every element every element ಈ ರಿಲೇಶನ್ ನಲ್ಲೇ ಇರಬೇಕು. Next, for symmetric, okay, in case of symmetric, here we are considering a ordered pair. Okay, we need to consider a ordered pair a comma b belongs to R. Okay, suppose if this ordered pair is present in the relation, and then exactly the reverse of this, that is b comma a. Okay, this b comma a should also belong to the relation. Okay, so if a comma b belongs to R, then b comma a must be present in R. Okay, then we can say the given relation is symmetric. Okay, and we need to check the symmetric condition for every ordered pair present in the relation. Okay, and then the last property is of transitive. Transitive a relation is said to be transitive. Okay, so here we are considering two ordered pairs, a comma b and b comma c. Okay, if these two ordered pairs are belonging to R, okay, and then the transitive case, it states that the ordered pair a comma c should also belongs to R. Okay, so if a comma b and b comma c belongs to R, implies a comma c belongs to R, and then we say the given relation is transitive. Okay, and if it exhibits all the three, that is reflexive, symmetric and transitive, then such a relation is called as a equivalence relation. It is said to be a equivalence relation. So equivalence relation is a relation which is exhibiting all the three types, that is reflexive, it must be reflexive, it must be symmetric, and it must be transitive. So if it is all three, then such a relation is said to be a equivalence relation. Okay, so we will, with this with the help of these definitions, we will try to solve the examples. Okay, so if you hope the definitions are clear. Okay, so once again revise the definitions. Okay, all the three definitions: reflexive, symmetric and transitive. Okay, so ಇಲ್ಲಿ important thing ಏನದೆ ಅಂದ್ರೆ always the relation is defined on the set A. Okay, so you need to identify in the question what is this set A. This set A can be set of integers, it can be set of rational numbers, it can be set of real numbers. Okay, so don't get confused with this R. This R, it indicates the relation, and always in relation we the elements are ordered pairs. Okay, in case of set only you get the single elements. Okay, and don't get confused with R here. If A is R, it indicates a real number, it indicates the Cartesian product of R and R. Okay, and this R, it indicates the relation. Okay, so we need to identify what set is given, and based on the set we need to define the relation will be defined. Okay, and by using the ordered pairs of this relation, we can identify whether it is reflexive, symmetric or transitive. Okay, so we will discuss the first question. Okay, so here the first question for today's class. Okay, we are considering the first question. Here what's given, relation R in the set A, okay, is equal to 1 2 3 4 up to 13 up to 14. Okay, so this is the set A, and the relation is defined as R is equal to x comma y such that 3x minus y is equal to 0. Okay, so we need to determine, okay, we need to check, okay, we need to check whether this is reflexive, symmetric and transitive. Okay, so out of these three, whether it is satisfying all the three or whether it is satisfying any one of these, we need to check it. Okay, so in the solution, so in the given question, see already, okay, the question, the relation whatever is given, it is given in a rule form. Okay, so first we will try to convert it in roster form. Okay, so see, first question we will discuss it in detail. See here the set A is given. Okay, so set A is having 14 elements. Okay, so A cross A will be the Cartesian product. So given relation will be subset of A cross A. So 14 into 14. Okay, 14 into 14, that many ordered pairs are there. So out of that, only few ordered pairs will be present in the relation. Okay, so we will find out which are the ordered pairs belonging to the relation R. Okay, Okay, so first what we need to do is we need to consider. Okay, so consider the given relation. Okay, and the set. Okay, so the consider r is equal to, see what is the given relation, x comma y. The question is for 3 marks, so every step is important here. So 3x minus y is equal to what? 0. Okay, is equal to 0. Okay, on the set a, on the set a. Okay, and we know a is 1 2 3 4 5. Also define a. Okay, a is equal to 1 2 3 4 dash 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 up to 14. So elements are up to 14. So first step what we will do is we will convert this relation into rule form. Okay, so to convert the relation into rule form, we need to make use of this condition. Okay, so see this condition, you can do it in the rough column ನಲ್ಲಿ ನೀವು ಮಾಡಬಹುದು. So this will be y equal to what? And 3x. Okay, y is equal to 3x is the condition. Okay, y is equal to 3x. Okay, so here we need to take, so x value now set a dintra tagobeku. Okay, so first we can start with 1. Okay, the first element of set a is 1. So when x is 1, see when x is 1, y will be equal to 3. Next, similarly when x is 2, okay, y will be equal to 3 into 2, it will be equal to 6. Next, when x is 3, it will be equal to 9. And then when x is 4, 3 4s, it is 12. Now see, this will be the ordered pairs. Okay, we can't take 5. Okay, so see when x is equal to 5, y will be equal to 15. Okay, y will be equal to 15, and see 15 is not belonging to a. Okay, so we need to stop at 12. Okay, so see when x is equal to 5, y will be equal to 15 for this given condition. So y equal to 15, it does not belongs to a, so we need to stop at 12. Okay, so this is the relation now. So we have formed the relation. So now one by one we will be checking the properties here. Okay, so we will first start with reflexivity. Okay, so for reflexivity, okay, in case of reflexive, so step by step we will be discussing. So reflexive, reflexive, you write down reflexive, and then see, yeah, here. Okay, now see, the condition, the definition of reflexivity condition ಏನದೆ ಅಂದ್ರೆ ಏದ ಪ್ರತಿ ಎಲಿಮೆಂಟಿಗೆ 1,1 2,2 ಈ ತರದ ಆರ್ಡರ್ಡ್ ಪೇರ್ಸ್. ಓಕೆ, ಸಿ if 1 is belonging to a, then the ordered pair what? 1,1. Okay, if 2 is belonging to a, then ordered pair 2,2. Okay, but you can see ಇಲ್ಲಿ ಏನ್ ನೋಡಬಹುದು ಅಂದ್ರೆ 1,1 ಪ್ರೆಸೆಂಟ್ ಇಲ್ಲ, ಇಲ್ಲಿ 2,2 ಪ್ರೆಸೆಂಟ್ ಇಲ್ಲ, 3,3 ಪ್ರೆಸೆಂಟ್ ಇಲ್ಲ. ಅಂದ್ರೆ ಏದ ಪ್ರತಿ ಎಲಿಮೆಂಟಿಗೆ, ಎವ್ರಿ ಎಲಿಮೆಂಟಿಗೆ ಆ ಆರ್ಡರ್ಡ್ ಪೇರ್ ಈ ರಿಲೇಶನ್ ನಲ್ಲಿ ಇಲ್ಲ. ಓಕೆ, ಸೊ ಅದರ ಸಲುವಾಗಿ we can directly write it, so we can write r is not reflexive. R is not reflexive. Okay, so when you are writing r is not reflexive, okay, you also need to write the reason, okay, why it is not reflexive. Okay, so what will be our reason? Okay, so here see 1,1, 2,2, 3,3 dash 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 up to what? 14,14. Okay, so these ordered pairs are not belonging to what? R. They are not present in R. Okay, for okay, so these are not present in R. Okay, so because of this reason, we say that R is what? Not reflexive. Okay, so if you are writing R is not reflexive, you need to give the reason. If you write R is reflexive, you need to give the reason. Okay, next we will discuss now symmetric. Okay, so symmetric, so see here for symmetric what we are doing is, how many ordered pairs are there here? 4 ordered pairs are there: 1 comma 3, 2 comma 6, 3 comma 9, and 4 comma 12. Okay, so for every ordered pair, the reverse image must be present. Okay, the reverse ordered pair must be present. So see here, if I consider 1 comma 3, okay, 1 comma 3, see 1 comma 3 is present in R. Okay, 1 comma 3 belongs to what? R. Okay, but what about its inverse? Okay, reverse will be what? 3 comma 1. Okay, so here the first element will change into second and second into first. See whether 3 comma 1 is present in the relation. 3 comma 1 is not belonging to the given relation. Okay, and because of this reason, we say R is what? R is not symmetric. Okay, R is not symmetric. Okay, now next, in case of transitivity, so for transitivity, transitive, okay, relation, or in case of transitive relation, okay, we need to check transitive relation. We need to check now by considering two ordered pairs. Okay, so we need to consider two ordered pairs such that, see, 1 comma 3 and 3 comma 9. We can consider 1 comma 3 and what? See, 3 comma 9. Okay, so see, with the property, the definition ಏನಂತದ ಅಂದ್ರೆ a comma b ಇದ್ರೆ ಅದರ ಜೊತೆಗೆ b comma c ಇರಬೇಕು. Okay, so ಈ ತರದ ಎರಡು ಆರ್ಡರ್ ಪೇರ್ we need to consider. Okay, we need to consider a comma b and b comma c. So ಈ ತರದ ಆರ್ಡರ್ ಪೇರ್ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ವು ಅಂದ್ರೇನೆ we can discuss the transitivity. Okay, so here, see, we can see 1 comma 3 and 3 comma 9 are present in the relation. Okay, but see, but the new ordered pair which is formed by these combining these two ordered pairs, 1 comma 9. Okay, see, 1 comma 9, a and c we have to consider. Okay, so this a comma c should also belongs to what? R. Okay, so according to the definition of transitivity, if a and b, okay, if a and b and b and c are present in R, then a comma c should also be present in R. Okay, but we can see 1 comma 3 and 3 comma 9 are present in R, but 1 comma 9, it does not belongs to R. Okay, it does not belongs to R, and since it does not belongs to R is what? Not transitive. Okay, R is not transitive. Okay, hope and the explanation is clear. Okay, so we have first discussed the reflexivity, symmetric, we are symmetric, and then transitive, and the above relation last statement you need to write. Okay, so the relation, whatever the given relation is there on A, it is neither reflexive nor symmetric nor transitive. Okay, so last sentence you need to write. Okay, what you need to write? R is not reflexive, symmetric, and what? Transitive. So it is neither of the above. Hope the first one is clear. Okay, first example is clear. Next we will discuss the second example. One more similar type example I will be considering. So first definition understand ಮಾಡ್ಕೊರಿ. ಡೆಫಿನೇಷನ್ ಗೊತ್ತಿದ್ರನ ಇದು ಎಕ್ಸಾಂಪಲ್ ಸಿಂಪ್ಲಿಫೈ ಮಾಡ್ಬೋದು ನೀವು. ಓಕೆ, ಸೊ ಡೆಫಿನೇಷನ್ ಎಷ್ಟು ಕ್ಲಿಯರ್ ಇರ್ತದ ಅಷ್ಟು ಈಸಿಲಿ ಇದು ಎಕ್ಸಾಂಪಲ್ ನೀವು ಸಾಲ್ವ್ ಮಾಡ್ಬೋದು. But the example is very easy question, and every year it is been asked for 3 marks. Okay, so we discuss the second example. Okay, so on the second example, we will discuss the second example now. Okay, so same type. Okay, so pay attention. Solution. So again, in the solution first part, what we need to do, we need to identify the relation. So here the relation is given, and the set on which it is defined, it is defined on the set of what? A natural numbers. Okay, so set is natural number. Okay, so the Cartesian product will be R cross R, and R is defined on what? N cross N. Okay, it is defined on the ordered pair N cross N. Okay, so pay attention here further. So first what we are doing is we are considering the relation. Okay, consider whatever the question is given, you write it once again. R is equal to x comma y such that y is equal to x plus 5, and x is what? Less than 4. Okay, x is less than 4, defined on, okay, defined on N. Okay, defined on the set of natural numbers, or defined on set N. Okay, so a capital N, it indicates a natural number. Okay, so again I will try to convert this given example in first roster form. Okay, this is already given in rule form, so write down the, we will write down the relation, we will write down this relation. in. Okay. Kirtana, just Rishabh Rishi of your video and audio. Don't disturb the other students. Okay, so R, first we will convert it in a roster form. Okay, so to convert, see here the condition is given same like the previous example. In the previous example, the condition was y equal to 3x. Now here the condition is y is equal to x plus 5. Okay, and see here they have put a condition on x. X condition ಏನದೆ ಅಂದ್ರೆ x the value 4 ಗಿಂತ ಕಡಿಮೆ ಅದೇ. Okay, so x first 1 ತಗೋಬಹುದು ನಾವು. Okay, so x is equal to 1. So when x is equal to 1, value of y will be 6, and when x is equal to 2, value of y will be 7. X is equal to 3, the value of y will be what? 8. Okay, and since x is less than 4, we can't take x is equal to 4. Okay, no doubt the set of natural number is an infinite set, but here there is a restriction on x. It is x is less than 4, so only we get three elements. Okay, we get ordered pair. Okay, so again one by one we need to discuss it. Okay, one by one we need to discuss the uh, conditions. So first one we need to discuss for a reflexive case. Okay, reflexive. So for reflexivity again, see same definition, same step we can write. Okay, R is not. Okay. So first we will discuss for reflexive. So R is not reflexive again. Okay, R is not reflexive. Okay, R is not reflexive. Again, the same reason you can write. See 1 comma 6, 1 comma 1. Okay, these ordered pairs are not belonging. See 1 comma 1, 2 comma 2. Okay, 3 comma 3, and such ordered pairs see are not belonging to R. Okay, but these all are present in natural numbers. These are elements of natural numbers, but the ordered pair consisting the same first element and second element. So similar element must be there. The first element also must be a, second element also must be a. So such ordered pairs are not present here. Okay, similarly in case of a symmetric, now in case of a symmetric, okay, in case of a symmetric, we will consider say 1 comma 6, 1 comma 6, any one ordered pair you can take. 1 comma 6 belongs to R, but we can see that 6 comma 1, okay, 6 comma 1 is not present in R. Okay, so according to the definition of symmetric, if a comma b belongs to R, b comma a should also belongs to R. But here 1 comma 6 is belonging to R, and 6 comma 1 does not belongs to R. Therefore again R is not symmetric. Okay, R is not symmetric. Next, last we have transitivity. Transitive. Okay, so in case of transitives, in case of transitive. Mhm. Okay, say according to the definition of transitivity, there is a condition. What condition is there? The definition of transitivity is if a comma b and b comma c, if these ordered pairs belongs to R, then it implies a comma c also belongs to what R. Okay, so if this definition is satisfied by the ordered pairs, then we can say the function is transitive. Okay, I okay. So here see, if these ordered pairs are not present now, if the ordered pairs which we require to define the transitivity are not present, in such case also the relation is what? Transitive, because we don't have any ordered pair to check whether it is transitive or not transitive. So we directly consider it as it is transitive. So here you need to write a reason. Okay, you need to write a reason why it is transitive. Okay, so the reason is since there is no pair. Okay, since there is no pair in R. Okay, in R, such that x comma y and y comma z belongs to. Okay, so we need not check. Need not check for the pair for the pair x comma z. Okay, so see, these two initial pairs are not there. Okay, so x comma z we did not check in R, so this relation will be transitive. Okay, so R will be transitive. Okay, so see, this relation is not reflexive. It is not reflexive. It is not symmetric, but it is transitive. Okay, but it is transitive. Okay, so the reason for transitivity is this: since there are no initial ordered pairs. Okay, ಇಲ್ಲಿ x, y ಮತ್ತು y, z ಈ ordered pairs ಫಾರ್ಮ್ ಆಗಂಗಿಲ್ಲ ಇಲ್ಲಿ R ನಲ್ಲೇ. So other the output that is x, z, such ordered pair also can't be properly checked here. Okay, so because of that R is transitive. Okay, this is the question number 2. Next, some more questions. So early in the first two questions I have discussed, very easy questions I have discussed. Next we will go for a tough question. Okay, but in the exams, maximum of the times, some easy questions will be asked. Okay, so these all questions are taken from your NCERT relation and function first exercise. Okay, exercise 1.1. So round about 12 questions, 12 to 14 questions are given there. Okay, so at least out of those which have repeated in the previous years, such type questions I am discussing. Okay, so 7 out of 14, at least 6 to 7 questions we will cover it in today's class. Okay, so hope you have understood the definitions now. So we will begin with the third example. Okay, so example number 3. Okay, so see, sometimes the question will be given in form of, okay, so the previous two questions what we discussed, there directly we can write the ordered pairs and check it. But sometimes the relation will be given in general form. Okay, so the proof also we can write it in a general form only. Okay, so if a limited ordered pairs are present in the relation, then we can directly take the ordered pairs and check whether it is reflexive, symmetric, and transitive. But if the number of ordered pairs which are forming the relation is vast, okay, in such case we can just use the general statements and simplify and check whether it is symmetric and transitive. Okay, so see, the first one, solution. We'll discuss this question. Question 3. So in the question 3, again we need to identify the set and the relation first. Okay, so in the solution, we first need to write. So see, the relation is defined. Okay, so R is equal to x comma y. Okay, such that y is divisible. Okay, y is divisible by what? X. Okay, on A, on the set A. Okay, so the set A is given. The set A is consisting of what? 6 elements. Okay, so here again the relation is defined on what? A cross A, and this is rough. A cross A. So R is defined on R is a subset of A cross A. Okay, so to write down the relation, we can write this in roster form. Okay, so here the ordered pairs of these relations will be the elements. So see, here the condition is y must be divisible by x. Okay, such elements only will belong to the relation. Okay, so if y is divisible by x, then the elements which are satisfying this condition will form the ordered pair. Okay, will form the ordered pair. Okay, so how to check whether it is divisible? Okay, so see here the first set and the set A is consisting of what? How many elements here? 6 elements. Okay, 1, 2, 3, 4, 5, and what? 6, and the second set is also consisting of what? 6 elements. It is consisting of 6 elements. Okay, it is consisting of 6 elements. Okay, so just try to understand this. Okay, it is consisting of 6 elements. 1, 2, 3, 4, 5, and what? 6. So this is the set A cross A. Okay. So now see, take the first element. Okay, first element, see 1, it divides all the elements. The remainder will be equal to 0. So 1 will form the ordered pair with each element. Okay. So see, 1 will divide every number. No, they are divisible. Okay. So see, 1 is divisible by 1. Yes. Next, 2 is also divisible by 2. Yes. 2 and 2, then 3 and 3, it is possible. 4 and 4 also it will form ordered pair. 5 and 5 will also form ordered pair, and 6 comma 6 will also be the part of this relation. Okay, because each every number divides itself. Okay, next, come to the next one now. Okay, so 1 comma 1, 1 comma. Okay, later what we need to do now. Okay, see, now see, 1 divides 1, no problem. 2 does not divide 1. Okay, 3 does not divide 1. 4 does not divide 1. 5 does not divide 1. 6 does not divide 1. Next, we need to consider the second number now, 2. Okay, so 2 is divisible by what? 2. 2 is divisible by 2. And also, 2 is what? Divisible by 4 also. Okay, it is divisible by 4. Okay, so 2 comma again what? 4. Okay. Next, you take the number 3. Okay, the number 3. So 3 only it is divisible by 3. Next, 4. 4 is divisible by itself, and also it is divisible by what? 2. Okay. It is also divisible by 2. So 2 comma 4 we have written. And then similarly what we have is after 2 comma 4. After 2 comma 4, 2 it divides 6 also. Okay, 2 divides 6. So 6 is divisible by 2. 6 is divisible by 2. And then, so 2 is over. Okay, so after 2, next we have 3. Okay, so 3, it divides only 6. Okay, so 3 divides. Okay, so 6 is divisible by 3. Okay, 6 is divisible by 3. Now see, 4 is divisible by 4. We have already taken. 4 does not divide 5. 4 does not divide 6. Okay, so this will be the part of the ordered pair. Okay, this will be the part of the relation. These ordered pairs will be the part of the given relation. Okay, so now using this using the roster form, we can check the condition. So first condition ಏನು check ಮಾಡಬೇಕು ನಾವು? Reflexivity check ಮಾಡಬೇಕು. So reflexive. So for reflexive, see here every element of a these a comma a, 1 comma 1, 2 comma 2, 3 comma 3, 4 comma 4, and 5 comma 5, 6 comma 6. So all these ordered pairs are already present. Okay, so we can write, okay, R is what? R is a reflexive relation. Okay, R is a reflexive relation. Okay, so here you can write every element or every number. Okay, every number is what? Divisible by itself. Divisible by itself. Okay, and since every number is divisible by itself, okay, itself, these all terms, okay, 1 comma 1, 2 comma 2, and dash 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 up towards 6 comma 6 are present in the relation, and therefore we say R is what? Reflexive. Okay, so if you don't mention the reason, you will not get the marks. Okay, so here I have written the reason. The general reason is every number is divisible by what? Itself. Okay, so this one line if you write and write R is reflexive, you will get full marks. Okay, next for symmetric now. So in case of symmetric, we need to take one ordered pair, any one ordered pair. So see, first 6 at least you can't take, because reverse of 6 comma 6 will be 6 comma 6. Okay, so now I will consider 2 comma 4. Okay, so see the ordered pair 2 comma 4. So when we consider the ordered pair 2 comma 4 ever consider ಮಾಡ್ತೇವಿ. Okay, 2 comma 4 is belonging to R, but the reverse of this 4 comma 2. See whether 4 comma 2 is present here. So 4 comma 2 is not present in the relation. Okay, so 4 comma 2 does not belongs to R. Okay, 4 comma 2 does not belongs to R. Okay, and therefore, what we can say, R is not symmetric. Okay, R is not symmetric. Okay, next we need to check now transitivity. So we will check the case of transitive. So in case of transitive, what we need to do is, okay, in case of transitive. So here we are considering two ordered pairs. Okay. So first, what we will do is we will consider let x comma y and what y comma z belongs to R. Okay. Now see if x comma y belongs to R. What is the meaning of the first ordered pair? Y is divisible divisible by what? Y is divisible by x. Okay, similarly the second ordered pair, z is what? Divisible, z is divisible, whatever the condition is there, you write, z is divisible by what? Y. Okay, see one simple example we will consider. I will consider 2 4. Okay, 2 4 and or say I will consider 2 2. Because we require the same elements. So 2 2 and 2 4. See, pay attention now here. See, 2 is divisible by 2. Okay, 2 is divisible by 2. Okay, 2 is, see, y is divisible by x, so 2 is divisible by 2, and also see z, this 4 is also divisible by 2. So indirectly we can say 4 is divisible by 2. Okay, or see, out of this given ordered pairs, if we don't consider these ordered pairs, see, suppose three numbers are there, 2, 4 and 8. Okay, if I consider these three numbers here, so see, 4 is divisible by 2. Okay, and 4 it divides 8. Okay, so 8 will also be divisible by what? Okay, so that is what the statement is here. See here, y is divisible by x and z is divisible by y, and therefore what we can write? We can write, okay, we can write that z is divisible by x. Okay, z is divisible by x. Okay, and since z is divisible by x, we can write, and therefore see, this given relation, it is reflexive and transitive, but not what? Symmetric. Okay, and since z is divisible by x, one last sentence, what we can write? Z comma x belongs to R. Okay, so we started by considering two ordered pairs, x comma y and y comma z, and we showed that z comma x also belongs to R. Okay, z comma x also belongs to R, therefore it is transitive. Okay, so this above relation is what? The relation is reflexive and transitive. Okay, but it is not a symmetric. It is not a symmetric relation. Okay, so this is how we can check whether the given relation is reflexive, symmetric, and transitive. Okay, so again, some more examples we will discuss. Hope you all are understanding, students. Those who have participated: Kirtana, Naveen, Rishabh, Vinushri, and all. Okay. Mm. So understand it again. Try to practice it. One that way sala, and you practice ಮಾಡ್ರಿ. But such kind of questions have been asked every year, same type. Whether the way you need to identify whether it is reflexive, symmetric, and transitive. Very important question in part C of the question paper. Okay, next. Okay, so the next one. So this question I have solved it already here. Okay, just we will be discussing. Okay, so see, pay attention. So question number 4. Question number 4. So the given relation. So see the relation R in the set defined on what? Set z of all integers defined as r is equal to x comma y. Okay, xy, ordered pair xy, such that x minus y is an what? Integer. Okay, x minus y is an integer. Consider r is equal to xy, x minus y is an integer. here on the set of what natural on the set of integers. Okay, here the given and the given function. Okay, the given function what it consists of. Okay, so first we will write it. So see the R is a subset of what now here and Z cross Z. Okay, so it is defined on integer set. Okay, so the integer set of integers is a infinite set. Okay, so Z cross Z will also have what infinite number of elements. Okay, so first we need to check the reflexivity condition. Okay, so see here the condition is x minus y must be a integer. Okay, x minus y must be a integer. Okay, now for reflexivity both the elements of the ordered pair will be same, x comma x. So if I replace this x with x here. Okay, so see in this given condition, so for reflexivity what we need to do, we need to check x comma x. Here we have considered x comma x. So when I consider x comma x and substitute in this condition, okay, we get x minus x. Okay, we get x minus x, and we can see that x minus x is equal to 0. Okay, and 0 is an what integer. Okay, so whenever you subtract a integer by itself, the answer will be equal to 0, and always we know 0 is an integer. Okay, so because of this the answer is again what is an integer. 0 is an integer, so we can say this is a reflexive relation. So R is what? R is reflexive. Okay, R is reflexive. Next, similarly, for the second case, for symmetric, now see for every x comma y belongs to z, see xy belongs to R. Okay, so xy will belong to R if x minus y is an integer. Okay, x minus y is an integer. So see if xy belongs to R, so here we are considering this general pair only, general ordered pair, that is x comma y. Okay, so when x comma y belongs to R, it implies that what x minus y is integer. Now see in x minus y, if I take minus sign common, okay, if I take minus sign common, we get, okay, if I take this minus sign common, okay, minus sign common, so it will be if I take out minus sign common, it will be y minus x, and y minus x will form the ordered pair y comma x. So see if the difference of two numbers is 3, or if the difference of two numbers is minus 3. Okay, both 3 as well as minus 3 are what integers. Okay, so if I consider x comma y, or if I consider y comma x, okay, both will be present in R, because the subtraction of x comma y and y comma x will also be a what integer. Because of that reason, the R is a symmetric relation. Okay, and then we need to check the transitivity now. Okay, so for transitivity, okay, so these generalized statements are important. Okay, so whatever format the solution is given, you try to practice it in that way. Okay, if you don't understand any step, you can ask again in the comment section. Okay, and then the last case here, the last case is of transitivity. So in case of transitivity, we need to consider two ordered pairs here. Okay. So the first ordered pair what we are considering is x comma y, and the second ordered pair we are considering y comma z. Okay. Now if x comma y is belonging to R, meaning of this is they are integers. The difference of these two terms will always be what integer. So x minus y will also be integer, and y minus z will also be a integer. Okay, next see x minus z, we can write it as x minus y plus y minus z. Okay, so see this is a integer, this is also integer, and sum of two integers will also be a integer. Okay, and the sum of this is nothing but it is equal to what? It is equal to x minus z, and this x minus z or x comma z which is belongs to R. Okay, therefore R is what? Transitive. Okay, so we consider two ordered pairs, and we show that the sum of the difference of these two ordered pairs is also a integer. Okay, so therefore R is transitive. Okay, so for such type of general questions, you need to give the statements or give the reason in general form. Okay, so one or two times you write it and practice it, so you will find it easy. Okay, next. Okay, next question, and a very important question. So this question has occurred 2 times in the annual paper. Okay. So question number five. Question number five. So we need to discuss this. See, the given relation is show that the relation R in the set R. Okay, defined by R is equal to A comma B, such that A is less than equal to B square, is neither symmetric nor neither reflexive nor symmetric nor transitive. Okay, so we need to show the relation is none of these. Okay, that is neither reflexive nor symmetric nor transitive. Okay, so see again in the solution part, first we need to consider. Okay, so in the solution part, write and take the definition of the relation. So the relation is A comma B such that A is less than equal to B square on the set of what real numbers. Okay, so here see, I had told you the given relation is a subset of what Cartesian product of real numbers. Okay, so R is subset of real numbers here. Okay, don't get confused with both the R's. Okay, or for real numbers, for the set you can consider it as, okay, for the real number set you can consider it in this form. Okay, so here I'll draw a line. Okay, it indicates that this is set of real numbers. Okay, so here see A is less than equal to B square. Okay, so this example we need to give the reasons in general form. Okay, so here if you remember some terms, some elements, it will be better. So see here, it can be, see, if I consider two real numbers, simple 1 and 2, okay, or 1 and 1, if I consider 1 and 1 or 1 and 2, so see 1 is equal to 1 only. Okay, 1 is equal to 1, so here condition is less than equal to. Okay, the condition is what? Less than equal to. So 1 will be equal to 1. Okay, but now when we consider, or 1 square will be equal to 1 square. Okay, but here when we consider, see now, if I consider 2 comma 2, 2 comma 2 also 2 will be less than 2 square, that is 4, so it will satisfy. So when we consider a non-fractional number, a non-fractional real number, it will satisfy and it will exhibit reflexivity. But here they are asking us to show it is not reflexive. Okay, to show not reflexive, we need to give an example of ordered pair where the condition fails. Okay, so see here we are considering, it can be observed that 1 comma 2 and 1 comma 2 does not belongs to R. Okay, why it does not belongs to the relation? Because see 1 comma 2 will be greater than 1 comma 2 square. Okay, and 1 comma 2 square is equal to what? 1 comma 4. Okay, so see the relation will belong to the ordered pair will belong to the relation. See this ordered pair will belong to the relation only if it satisfies the condition A is less than equal to 1 by 2 square. Okay, but when we try to use the condition here, see 1 by 2 is A. Okay, but see when we take the square of this 1 by 2 square, it will be equal to 1 by 4, and 1 by 4 is what? 0.25, whereas 1 by 2 is 0.5. So 0.5, okay, can't be, it cannot be what? It cannot be less than what? 0.25. Okay, so and because of this, R is what? Not reflexive. Similarly, for symmetric, we are considering 1 comma 4 belongs to R. So 1 comma 4 belongs to R because 1 is less than 4 square. But when we try to take the reverse of this, 4 is not less than 1 square. Yes, 4 is not less than 1 square. So 4 comma 1 will not belong to the relation R. Okay, it will not belong to the relation R. Okay, and because of this, R is not symmetric. Okay, R is not symmetric. Next, same way we need to check for transitivity now. So in case of transitivity, first we need to consider the examples. We need to consider the example where it is exhibiting the conditions. Okay, so we are considering two ordered pairs here. So these two ordered pairs you can see 3 comma 2 and 2 comma 1.5, they are belonging to R. Okay, see 3 is less than 2 square, so this ordered pair is present here because see 3 is less than 2 square, and since 3 is less than 2 square, 3 comma 2 can be considered as the ordered pair. Similarly 2 comma 1.5 consider ಮಾಡಿದ್ರೆ ಏನಾಗ್ತದೆ 2 will be less than 1.5 square. Okay, so this 2 comma 1.5 will also satisfy what? It will also satisfy the relation. Okay, it will also satisfy the relation. Okay, so this is satisfying the relation. Okay, now see, but when we consider see 3, so see here, pay attention. 3 comma 2, and again what we have considered 2 comma 1.5. Okay, so lastly what we need to do is we need to check 3 square is less than 1.5. 3 square is less than 1.5, and then it will be part of the relation and the function will be transitive. Okay, but see here we have checked it 3 is greater than 1.5 square. It is greater than 1.5 square, and 1.5 square is what? 2.25. Okay, so the prior to ordered pairs are present in the relation. See, x comma y and y comma z is belonging to the relation, but x comma z does not belong to the relation. 3 comma 1.5 relation ಗೆ part ಆಗಂಗಿಲ್ಲ. ಅದರ ಸಲುವಾಗಿ we can write r is not transitive. Okay, r is not transitive, so therefore r is neither reflexive nor symmetric and not transitive. Okay, so for this example very important. Actually 3 questions are there in your book. Okay, one is a less than equal to b, a less than equal to b square, and one more question is for a less than equal to b cube. Okay, so practice all these 3 questions. Okay, most of the time these questions have repeated. So just now we have discussed this question, a less than equal to b square. Similarly I will try to discuss this question also, a less than equal to b cube. Okay, so pay attention. Okay, so this simple example is given here. So you can check this question also has occurred one time in the exam. So check whether the relation R defined on the set 1, 2, 3, 4, 5, 6 as R is equal to A, B is equal to A plus 1. Okay. So already the first 2 questions we have discussed, it's similar to that. You will try to solve it for homework. Okay. Next, we will discuss a question on inequality again. One more question. Yes. Okay. So in the last case, we discussed a less than equal to b square. Now, similarly, here we have a question on what? A less than equal to b. Okay. A less than equal to b. Okay. So same again. Again, it is defined the given question. You can see it is defined on. Okay. It is defined on. Okay, the set of real numbers only. Again, the question is defined on set of real numbers. Okay, so we can see the given function. The definition of the relation is R is equal to AB such that A is less than equal to B on the set of real numbers. Okay, so again for real numbers, so see A less than A belongs to R. Why? Because see, we can say A is equal to A. Okay, A can be equal to A. So either one condition it should satisfy. Okay, so A equal to A, it will satisfy. So R is reflexive. Next, similarly for symmetric, we are considering an example 2 comma 4 belongs to R. Okay, why 2 comma 4 belongs to R? Because 2 is less than 4. But we can see 4 comma 2 does not belongs to R because 4 is not less than 2. 4 is not less than 2. And because of that, we can say 4 comma 2, this 4 comma 2 element is not part of the relation. Okay. Similarly, now in case of transitivity, we are considering two elements. We are considering two elements. Okay, so see when we consider two elements here, a comma b belongs to R. Okay, a comma b belongs to R. Okay, and see a comma b belongs to R and b comma c belongs to R. Then we can see a is less than b obviously, and b is less than c. So a will be also less than what c. So a comma c will belongs to R. So R is what? Transitive. It's just like three people are standing height wise. Okay. So person A, okay, this is person A, this is person B, and person C. So A is less than B, B is less than C, then automatically A will be what? less than C. Okay, so because of this reason, A will also be what, less than C. So R is transitive. So this is the relation is reflexive, symmetric, reflexive and transitive, but it is not symmetric. Okay. Next, similarly, we will discuss one more last question based on A less than equal to B cube. Okay, that one question we will discuss and then stop. Okay, so so all these three are very important. A less than B, okay, A less than B, A greater than equal to, see these three questions. A less than equal to B, A less than equal to B square, and A less than equal to B cube. Okay, only these three questions are tough. And then the divisibility questions are there, and some questions are there on this direct linear equations. So this linear equation questions very easy to check whether it is reflexive and symmetric. Divisible also it is very easy to check. Only the problem is with these questions. Okay, so such type of questions you practice it. All the three questions I have discussed. This is the third question. So again, the same condition is been given here. R is equal to AB, A less than equal to B cube defined on the relation R. Okay. So we can see it can be observed that 1 comma 2 and 1 comma 2 does not belongs to R. As same condition we are using, 1 comma 2 is what, less than 1 by 8. Okay. Actually 1 by 8, see the function, the condition in the relation is A must be less than B cube. But when we cube 1 by 2, when we take the cube of 1 by 2, it is 1 by 8, and 1 by 8 is less than 1 by 2. So because of that, R is what, it is not reflexive. Okay, R is not reflexive. Similarly for symmetric, see 1 comma 2 belongs to R, 1 comma 2 belongs to R, because 1 is less than 8. But when we reverse it, 2 is, say, not less than 1 cube. Okay, 2 is not less than 1 cube, and because of that, R is not symmetric. Okay, and then the third example, the third case is transitivity, a very important third case. So third case, what we need to do is the example over here. Okay, third case. So see, we are considering two ordered pairs, 3 comma 2 and 3 by 2, comma 3 by 2 and 6 by 5. Okay, so these are the ordered pairs which are satisfying the relation. Okay, because 3 is less than 3 by 2 cube, and 3 by 2 is less than 6 by 3, 6 by 5 cube. Okay, but when we consider 3 and 6 by 5, when we consider 3 and 6 by 5, so 3 will not be less than 6 by 5 whole cube. Okay, and because of this reason, again, R is what, not transitive, and hence R is neither reflexive nor symmetric nor transitive. Okay, so we have discussed all the three questions based on inequalities. Okay, so these are the three more questions. These are the three more questions. Okay, and simple two more questions are there. Okay, which just if possible I'll try to discuss it in the next class, or you can take this for homework. Okay, you all try. Mhm. See the next question here. The next question is simple question is given. Show that the relation R in the set 1, 2, 3 given by. So already the relation is given 1, comma 2 and 2, comma 1 is symmetric, but neither reflexive nor what transitive. Yes. So see, easily you can prove it. Try to do it for homework. Next, a very important question. Hmm. A minus B. So this is the last. We will be discussing this and then stop. Okay. So see here, the given question is show that the relation R in the set A given by R is equal to mod of A minus B is even. Okay. So for here, see, the mod of A minus B must be a even number. The condition for the relation is a mod of what, A minus B is even. Okay. So here we can see for element A belongs to A. If any element of the set A we consider, always A minus A, mod of A minus A will be 0. And we know any number which is ending with 0 will be what, even number. Okay. So R is reflexive. Similarly, for symmetric, A comma B belongs to R, meaning is, see, mod of A minus B is even. So whenever we reverse it, it will be minus mod of a minus b, which is equal to b minus a, will also be even. So a minus b is also a even number, and mod of b minus a will also be a even number only. Okay, 2 you write or you write minus 2, both value will be what, even number. Okay, so because of that, b comma a will also belongs to r. So r is a symmetric. And then in case of last case, that is the transitivity case. Okay, so in case of transitivity, we are considering, see, two ordered pairs. So in these two ordered pairs, we are considering a comma b belongs to r and b comma c belongs to r. Okay. So see, if a comma b belongs to r, ಅದರ ಕಂಡೀಷನ್ ಏನದೆ ಅಂದ್ರೆ a mod of a minus b even ಆಗ್ತದೆ, ಮತ್ತು b comma c belongs to r ಅಂದ್ರೆ b mod of b minus c is also even. Okay, and now when we combine this, see, a minus c can be written as a minus b plus b minus c, because minus b and plus b will cancel out. So we can see mod of a minus c is also what, even, because even number plus a even number will also be a even number. Okay, so for that reason, a comma c will also belongs to r. Therefore r is a transitive relation. Okay, so these were some of the important questions, which have occurred for 5 marks. Okay, 3 marks. And in the next class, we will discuss the 5 mark questions. Okay, and uh, using these, you can again go through the examples from exercise 1.1. Okay, for some extra questions. Okay, so we will stop here. Okay, and this is one more same question. Okay, same type question, which is divisible by 4. Okay, so it is divisible by 4. The question is same. Just there a minus b was even number in the previous question. Here it must be a multiple of 4. Okay, so only even number you need to change by 4, and the same you will get, it is reflexive, symmetric, and transitive. Okay, this is the last question over here. So we will stop the class over here. Thank you, students. Okay, so we will meet you in the next class. Okay, bye.